Hello, good afternoon. This is Sharad Jain from EC Department, IPS College. So today we'll learn about the full wave rectifier. Initially, before that, before starting the full wave rectifier, in the previous classes we had discussed about the half wave rectifier. In the half wave rectifier, the output is obtained for the positive half cycle only. However, it is somewhat different from the half wave rectifier. In full wave rectifier, we get the output for both cycles of input. So this is the circuit diagram. Here we can see we are using here a transformer, and this transformer used here is center tap transformer having center tapping. So this is the primary section of the transformer. This is the secondary section. Secondary section we have this one tapping exactly in the middle of the secondary winding, so we are getting the output voltage here and here also. Both voltages are same in opposite polarity. This is the transformer's primary connections. We are connecting the AC mains to the transformer primary. Source voltage is there, input voltage is there. So whenever a positive half cycle is there, we are getting the polarity like that. This is positive, this is negative, this is positive, this is negative. So we can see voltage is induced in the upper half of the secondary, and the same voltage of opposite polarity is also induced in the lower half of the secondary. Same voltage. So we can say if V voltage is there, V voltage is also there. So total voltage is 2V plus minus series connection is there. So what happens? Let us see how the full wave rectifier works. During the positive half cycle, when this end is positive, this end is negative, the voltage that has obtained the secondary are like that. This is positive, this is negative. So V2 voltage is there, V3 voltage is there, Vm sin omega t, same voltage is induced here, Vm sin omega t, but opposite polarity. So we can say we get the voltage between across the secondary winding, that is twice Vm sin omega, this one plus this one. So under positive half cycle, the anode is positive, and this diode, the anode of this diode is negative. So we can say the only possibility of become forward biased is only for diode D1, not for D2. So under this condition, during the positive half cycle, diode D1 becomes to be forward bias and D2 becomes to be reverse bias. So diode D1 will conduct, it will supply the current, it will allow the path to flow in the current circuit. So the current will flow from here, diode D1 and load resistance like that, positive to negative. Since this is open, so no current will flow in the lower half of the secondary transformer. So during the positive half cycle, the current will start to flow from D1, or D1 will act, D2 will not be acts. However, during the negative half cycle, when this end is negative, this is positive, negative, positive, this is negative, this is positive, negative, positive. So we will see here, due to the negative voltage at the anode of the D1 and the positive voltage at the anode of the D2, the diode D2 becomes to be forward bias and D1 becomes to be reverse bias. However, in this condition, during the negative half cycle, the diode D2 will start to conduct, and the current will flow now from here to diode D2 and to load resistance. So now the diode D2 will be conducting and D will not conduct. Okay. So during the positive half cycle, the diode D1 conduct, D2 does not conduct. During negative half cycle, the diode D2 conduct, D1 will not conduct. So we will get the output current at the load during the both half cycles of the input. For the positive half, we will get the output due to D1, and for the negative half, we will get the output diode D2. However, we will see one important point here. Whenever the positive half cycle is there, the current will flow from the load from here to here, positive to negative direction. Now when the D2 conduct, the current still flow in the same direction, so we will get the output current in the same direction. We can see it from the waveform like that. This is the diagram which is showing during the positive half cycle condition. So diode D1 will conduct, the current will flow like that, and it will not conduct, so no current will flow from here. So what happens in the negative half cycle? In the negative half cycle, this diode D1 becomes to be reverse bias, and the current will flow due to D2. However, we can see from both diagram the current flowing through the load is same. Here the current is flowing from here to here, means positive end to negative end. Also the current is flowing from here positive to negative end. So in the waveform we can see here, this is output voltage for the positive half cycle due to conduction of the diode D1. This one is the output voltage due to diode of conduction, due to conduction of diode D2 in the negative half cycle. The process repeats D1, D2, D1, D2. So however, when we go to find out the average DC output voltage, we can get the this is a V average voltage. However, it is somewhat more than the half wave rectifier, as we see, because in the half wave rectifier only one cycle becomes to be responsible for giving the output. However, still we can see some ripples are there, means some AC components are there. If we want to get some smooth output, that is smooth DC, we will have to add one capacitor. Here we use a capacitor filter, so the capacitor filter is added in parallel to the resistor. So what will happen, we can see from here, the capacitor will give the smooth DC. You can see here, this is the output due to D1, this is the output due to D2, this is the output due to D1 and D2. Here we can see the capacitor will start to charge whenever voltage becomes to be greater than some specific voltage. So here the capacitor will start to charge. After charging up to the peak value of the output voltage, the capacitor becomes to be discharged. When the capacitor becomes to be discharged, here the second half cycle will start to give the output voltage. Whenever the output voltage become to be more than the capacitor's voltage, it again becomes to be charged. So this cycle repeats. So we can say the output voltage which having ripples now converted into like this due to the action of the capacitor. So we get somewhat smooth output, means we can say the amount of ripple in the output is now somewhat lower. So this is the interval which shows that it capacitor charge from T1 to T2 and it will discharge from T2 to T3. Again the capacitor start charge from T3 to T4 and so. Thank you.